Hi everybody. In this video we want to introduce a new imaging technique which does not use the fluorophores and the fluorescence phenomenon. It's somehow similar to the way that the blind people can read. They cannot see anything. They just move their fingers on these specific books, and they, by the feeling that they can realize what is exactly written on the book. Now let's get into the details of that imaging technique. This is called the atomic force microscopy. Well, this technique gives us the two-dimensional and sometimes the three-dimensional structure of the surface of the materials that we have, of the compounds that we are imaging. And the main feature of this microscope, this microscopic technique, is the cantilever. Okay, you can somehow consider it as the fingers of the blind people. It will move on the XY plane of our sample and feel the structure, the outer shell of our sample. Well, this cantilever is connected into the piezo, okay, and if we want to see, for example, here we are going up, here we are going down, and how we are moving on the outer shell of our sample, we can emit later on the top region of our cantilever and check the variation of the emitted light here. Okay, depending on whether the cantilever is going up or down, the light emitted here will also go up and down. Okay, so this is the basic concept behind the AFM. We can use it in two different approaches. The first approach is the contact mode, at which the cantilever is in contact with our sample, and it somehow may lead into the break of the cantilever, or destroying our sample. But through the second approach, we can use the intermittent contact. It is not physically in contact with the sample. The cantilever here is vibrating with a certain frequency, and when it feels the difference in the length here between the sample and the cantilever, this frequency of vibration will change, and with respect to that we can consider how the outer shell of our sample is changing. Here are some pictures that you can see. They have been taken by the AFM. You see the outer shell of our samples, and let's go to two other applications of the AFM. If we have the targeting ligand and here we have the receptor and they bind, we can by the use of AFM we can measure the strength of this bond, and sometimes we can also use the AFM for measuring the cell elasticity. Okay, we will apply a force on the surface of the cell, and with respect to the deformation that happens, we can calculate the cell elasticity.